Today we're going to talk about triangle proofs and Cpctc. So, what is Cpctc? If you've said corresponding parts of congruent triangles are congruent, then you're right. I know it's tempting to say congruent parts, but it's not. Remember, it's corresponding parts of congruent triangles are congruent. Basically, it's saying that if you have two triangles that are congruent, each of the parts, each of the sides, each of the angles are also congruent. So, when do we use it? Most of the proofs that we've looked at so far are asking us to prove that one triangle is congruent to a second triangle. But occasionally you'll have a proof that asks you to prove that an angle or a side on a triangle is congruent to an angle or side on another triangle. When a proof is asking you to prove that a part is congruent, such as an angle or a side, then the way that we go about that is typically just to prove that the whole triangle is congruent to the other triangle. Once we've proved that the triangles are congruent, we can say that that particular portion or given part of the triangle is congruent because of Cpctc. If the whole triangle is congruent, then each given part is congruent. Let's take a look at an example. So this is a pretty basic proof. And as you know, the first thing we always start with is our given information, because the math gods have been kind and they have bestowed upon us the knowledge that we need to prove congruency. So we have some information, then we have a diagram to the right, also part of our proof. And then also, if you look at the prove line, or what we are supposed to draw as our conclusion, it's not actually that the triangles are congruent. We're trying to prove that angle BCA is congruent to triangle DCA. So in this case, we need to prove that a part of the triangles are congruent. Instead of proving the part, it's easier to prove that the two triangles are congruent and then to draw the conclusion that therefore that angle is congruent. So let's go about proving that the triangles themselves are congruent. All right, so we've been given enough information basically to prove it relatively easily. We have AB, side AB is congruent to side AD. Nothing tricky about that. They just gave us some info. Easy per cheesy. Got one congruent side already, 1/3 of the way there, right? Reason? Best reason possible, because it was given. Behold, our universe now contains information. All right, now we have a second piece of given information. Again, just a straightforward that side BC is congruent to side CD. All right, so side BC congruent to side DC. Outstanding. No extra work needed, just given to us. 2 out of 3 parts, and we're good to go. Now we have a side and a side. So if we look at all of our types of congruencies, we have side, 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 angle, side, angle, angle, side, and angle, side, angle. We can also use hypotenuse leg, but we don't have any information about right triangles, so it's not that one. We haven't been given any information about angles, so it's probably not angle, angle, side. So it has to be one of these 3. What other piece of information are we able to easily conclude? Well, we have a reflexive side. We know that AC is equal to itself. That's always helpful. So we can say that AC is congruent to itself. AC is congruent to AC. Why? That's right, reflexive property of equality, baby. That will keep coming up. Reflexive POE. Property of equality. Okay? Now we have a side, and a side, so we have proven these two triangles are congruent. So triangle, and make sure we're matching up our corresponding parts in our congruency statement. Triangle A, what matches up with A? Well, they both share A. Then from A, we can go to B. So A, B, and B corresponds with D. So A, B, A, D. And then our third would be C, which again is a shared portion. So triangle ABC is congruent to triangle ADC by side, side, side congruency. So now that we have proven that these two triangles are congruent, we know that the angles have to be congruent, because if the whole triangle is congruent, then each and every part is. So we can finally draw our proven conclusion of BCA being congruent to DCA. And for our reason, we're going to put corresponding parts of congruent triangles are congruent, Cpctc. There is never a need for you to write that out. Cpctc is how you will typically see it viewed and is a sufficient way to write it, okay? Why don't you go ahead and give the second one a shot, and we'll go through it in just a moment. Okay, so let's take a look at the approach for this one. So I started off with the given information that QPS is congruent to SRQ. It's always nice when they just give you an angle. Now, the other piece of given information is that we have parallel lines. Anytime that you see that you have been given parallel lines, that should clue you in to the fact that we're going to be looking for other pairs of congruent angles. So we know that PS is parallel to QR. Remember, that's typically shown with an arrow, like this, right? And we have a transversal also that we can use to help us right through here. Now, there's an interesting conundrum that we have now come to. Using alternate interior angles, we can prove this angle is parallel to this angle. So now we have PSQ is congruent to SRQ by alternate interior angles. Hopefully you were able to get to that. Okay. Would you be able to prove the other angle, QSR? It kind of looks like you should be able to, but remember, the alternate interior angle here would include all the way up to our parallel line. So it would include the angle plus some of the exterior space. So we can't actually prove the other angle congruent, just as a reminder. But we have two angles, and that's enough to get us well on our way to proving congruency for the entire triangle, because we can also say that SQ is congruent to itself. So SQ, line SQ is congruent to line segment SQ due to our favorite reflexive property of equality. And at that point, we should have angle, angle, side. Now you'll notice that the side that we have been given is not the one that is connecting the two angles. So it is not included, which means that it is angle, angle, side. Okay, so we now have triangle QPS is congruent to triangle SRQ. Right? And once we know that the triangles are congruent, we know that the side that we're trying to prove congruent, PQ, oh, I wrote an R, probably not R. Let's try that again. PQ is congruent to side RS. Okay, and that is congruent by corresponding parts of congruent triangles are congruent. Cpctc. All right, so we have 1, 2, 3 more proofs. I'd like you to go ahead and try to do those proofs on your own. I feel like you can probably handle it. And then you can check your work with your neighbors and check the key on the slides once everyone's done, or you can go up and ask teacher, and they'll be happy to let you see the key and check your work. So try these 3 on your own, check with your neighbors, check with the teacher, and see how you do. Remember that the process is that you're going to state your givens, draw conclusions from the givens that will allow you to prove the two triangles are congruent, and once you've proven that the triangles are congruent, you can prove that the parts are congruent by corresponding parts of congruent triangles are congruent, Cpctc. Thank you. Bye.